Now, we will come to another example. Find the center of mass of a triangular lamina. Now, the lamina is LMN, may be subdivided into narrow strips, each parallel to base MN as shown in the figure. So here base is MN and strips are parallel to MN. So it is 1, 2, 3, 4, 5, 6. It means total number of strips including MN will be 6. Now we are finding L is the vertex, M is the vertex, N is the vertex, P is the middle point of MN, Q is the middle point of LN, and R is the middle point of LM. Now the line joining L with P, the line joining M with Q, the line joining N with R, all these lines are called the medians, and medians intersect at G. G is called the centroid of the triangular lamina. Now we find G is a centroid. It divides the median in the ratio 2:1. The bigger part is 2, the smaller part is 1. Now in the lamina, LMN may be subdivided into narrow strips and each parallel to the base MN as shown in the figure. By symmetry, each strip has its center of mass at its midpoint. If we join the midpoint of all these strips, we get the median LP. The center of mass of the triangle as a whole has to lie on the median LP. Similarly, we can argue that it lies on the median MQ and NR as shown by the dotted lines. This means that the center of mass lies on the point of concurrence of the medians, that is on the centroid G of the triangle. Now in another example, find the center of mass of the uniform L-shaped lamina, a thin flat plate with dimensions as shown. The mass of the lamina is 3 kilograms. The whole mass is 3 kilograms. Now we will choose X and Y axis as shown in the figure. We have the coordinates of the vertices of the L-shaped lamina as given in the figure. We can think of L shape to consist of 3 squares, each of length 1 meter. The mass of each square is 1 kilogram. That is given in the example. Since the lamina is uniform, the center of mass C1, C2, C3 of the squares are by symmetry their geometric centers and have the coordinates 1 by 2, 1 by 2, 3 by 2, 1 by 2, 1 by 2, 3 by 2 respectively. Now, we take the masses of the squares to be concentrated at these points. The center of the mass of the whole L-shaped XY is the center of mass of this mass points. So, the figure is shown. We find that 0, 0 is a origin coordinate. Then there is a point A whose length is 2 on the x-axis, and on the y-axis it has no breadth. It is now A coordinate will be 2, 0. Similarly, coordinate B of the square, that will be 2, 1. That is 2 is the length of the particle and 1 is the height of the particle. And C1, C2 are the center of masses. Now we take D1, the coordinates are 1, 1. It means length of the point is 1 on the x-axis and breadth is 1 on the y-axis. And the center of mass is C3. Now in the above square, we find F is 0, 2. That is, means there is no number on the y-axis, there is no number on the x-axis, but 2 on the y-axis. So it means the particle or the atom has no length along x-axis, but breadth 2 along y-axis. Similarly, 1, 2, 1 is the length of point E on the x-axis, and 2 is the breadth of the same point along y-axis. Now we use the formulas for the center of mass of x and y, which we have discussed earlier. We compute the values. So x we will receive as 5 by 6 meter and y we will receive as 5 by 6 meter. Now we come towards another example. A rod of length L has non-uniformly distributed mass along its length. So the whole length is L, but the masses are not uniform. For its mass per unit length varying with distance x from one end as m naught over L square into L plus x. Find the position of the center of mass of this system. So here the whole length of the rod is L, but the masses are non-uniformly distributed, not equally distributed. Now, first of all, mass of the element of length dx, where dx is the small length of the whole length L, and we find that mass of this element is df. dx is the small length and its mass is small mass, that is df. We find the mass of the element will be given by m naught over L square into L plus x into dx. Now we take the center of mass of x. So what we do, we integrate the function from the limits 0 to L in the numerator as well as in the denominator. There is integration of x dm and integration of dm, but limits will be from 0 to L. Then we compute the value of dm as shown in the above line. It is m naught over L square into L plus x into dx. So by putting these numbers and integrating the function, we will come to conclusion that x center of mass is 5L over 9.